Hi. Okay, continuing on. So just to let you know, as I was saying before, with my logic, I needed more than 66 steps because I think I have 12 turnout decoders for signal decoders, and which requires more than 66 different combinations, aspects for to turn the different lights on, red, yellow, green. You also have a lunar option, which I don't use. And some people, if you don't use the yellow, you just use signals that are red and green. Now you have more steps to use that would take up the yellow aspects if you're only using red and green. But in my case, I use red, yellow, green. So, and some people might use flashing yellow. So then that would, again, get more complicated, require more steps, and so forth. So the other things I wanted to point to was here, there's some connectors that are along the edge of the board here and here. And what those are to connect, let me see, they're inputs from block detection, block occupancy, or switch state control. And on the other side is outputs for LEDs or tortoise switch machines. And then they have two, you'll see it, and I actually have a servo connected here. So there's two inputs for one behind each other, two on that board and then two on this board. So what's neat is if you have some railway crossings and you have some, with the signal that goes up and down, which goes across the road, you have that that board that goes up and down. You might want to control it with a servo. Well, since there's no servo input on the signal decoder, the SHD2. Well, since this guy is controlling all those signals and all that stuff, you can set it up in the logic that when a certain block is occupied, turn on those lights, turn on the signal. Use the SHD2 to operate the railway crossing, but then also use this board to operate two servos. So let's say one in each direction, one in each direction to operate the servos. So that gives you that. Let me see what else there is to talk about that board. Yeah, so since if you're using Team Digital's block detection circuit, they have a local net connection, and their block detector uses those type of coils where you run the wire through a coil once and then back to the track, and it's with resistance. So that's how it detects the train, the locomotive is there. It won't detect with that type of system. It won't detect the rolling stock unless you have resistance wheels or a resistor across the wheel. So it would only be picking up the locomotive. So you have to think about that when you set up this type of system. The other thing is, if you're using their other board, which does like I said, the block detection, then that information is fed to these signal logic boards. Through the central signal controller boards, that's the CSCe board. It's sent to them through the local net connection. So you don't have to make a physical. The only physical connection is that RJ45. So it's getting the information through the RJ45, just like the SHD2 decoders that are back here. Anyway, they connect through the DCC signal. So they're not connected through the logic, the local net, but they're connected to DCC, which this guy is also DCC. You could see here the yellow and blue connection that goes to the track. But like I said, for the block detection, that information is coming over the local net because you're using their board. If you don't want to use their board, you want to use something else. Like they also have some block detector sensors. I think it's called a DB2 or DB22, and that has a physical high-low output. So you would wire that to the board. And in this case, you see I have one that's actually wired up here because I needed because I have one independent track off to the side, and I don't want to dedicate 8 because going back to that block detector board, each one does 8 blocks. So I didn't have an area where I had 8 close. It was only one by itself. I didn't want to install one board there, so I got a DB22, installed that little guy there, ran the wire back to this board, which has the input there. So that's it. And as far as the other blocks that are in my yard and stuff like that, I'm not using Team Digital's block detection system. I'm using a let me see, what they call a S88 bus, and I'm using that connected to my command station, which is, let me see, I can probably point to a little board here. See, this board here, this is DigiKey's, their block detection, which uses this S88 technology. It goes to the command station. So now, because it's going to the command station, and then the command station interprets the S88 signal, but that S88 signal can go back to, through the local net connection, back to these boards, the CSCe boards, and tell them that the block is occupied. So I have a S88 block detection that you see there, and I have a 2 or 3 more around the layout, but I also have a block detection that is a local net. So and that connects to this board. So basically what's happening is, even though these boards are these block detection are what they call S88, they plug into DigiKey's block detector, which has a S88 input, but then it has a local net output. So yeah, they don't have to talk to the command station. They're all wired to that one that does both, the S88 and local net, and then that local net talks to this guy. So it becomes a self-contained system. You don't need the actually, once you set up all the logic and all of that going, you don't need the command station to at all. You can have a DC system if you wanted. All this stuff is talking to all these pieces are talking to each other. And the way the signal goes to the track is, there's a little board here. This one here, it's called the DCC boost. And you can see here there's a yellow and blue, which is the DCC output, which powers, there's an input plug here, a barrel that goes to power supply. Then this is output to that accessory bus, which all these boards are connected to. And then there's a local net connection that talks to that board. So that boost circuit guy, let me see what information I have. Yeah, he can operate, which the way I'm using now is in the command station mode. So now the turnout decoders, which is, you'll see one over here, SMD84. These turnout decoders, and then these other boards, and the signal SHD2 boards, they're all being powered on that bus. And since it's command station mode, what happens is all the signals, when they're going to go, let's say they have to output on the DCC signal, well, that little booster not only supplies the power, but what he also does is he takes that DCC signal that's on the local net, and he transfers it, changes it to a DCC signal, and then puts it on the bus, the accessory bus. So everything talks to each other. So that booster can operate, let me see what they call it, just as a power district booster, or an accessory mode, or command station mode. So in the basic booster mode, the output follows the DCC signal input. If the input DCC turns off for some reason, then the DCC boost turns off. In accessory mode, the DCC output continues to send DCC power regardless of the DCC signal input. This keeps accessories from shutting down due to track short circuits or overcurrent protection. And as I was saying, the command station mode is the DCC boost converts switch and signal messages on the serial bus from the CSCe, which is the central signal controller, to DCC packets to control the SHD2s. It also powers the SHD2s and other compatible accessories. It requires 12 to 14 volts, and current shutdown is about 4.6 amps. Alright, I need to charge my battery, so next video I'll be talking about the SMD84 turnout decoders. Thanks for listening.